Hello again. Um, in this lecture, we are going to learn the third approach, the critical value approach. In the critical value approach, we are going to make the decision directly based on the sample average. So earlier, from the sample average, we calculated the t-statistic, and from the t-statistic, we calculated the p-value. So we are going backward. We are going to we are reducing the steps, and now we are going to we are not converting the sample mean to anything at all. So we will reject our hypothesis if the sample average is too much different from your hypothesis. If not, you do not reject, right? So then the question is, how close is close enough, or how far is different, too much different? That is similar to the confidence interval approach. We will allow a plus minus certain margin around your hypothesis. Say my hypothesis is 100, and my hypothesis is 100, but I am going to accept my hypothesis if my observation is within plus minus 10 around my hypothesis, for example. So the margin depends on your significance level and your data, but so it will be determined later. So, but here let me define a few terms. These thresholds. So if x bar lies between a certain interval, then you will not reject the null hypothesis. You will not reject, and we call these two endpoints of the interval will be called as the critical values. So the critical values. So the right hand side, the larger side is called the upper critical value, and this is the lower critical value, denoted as critical value up, critical value low. So CU, CL. And they are from the null hypothesis value plus M plus margin minus margin. So plus minus margin. And the between those two critical values is the interval where the null hypothesis is accepted. So this area is called the acceptance region. So acceptance region, if the sample average is on the acceptance region, your null hypothesis is not rejected, will be accepted. However, if on the outside of the critical values, so lower than the lower critical value or larger than the upper critical value is outside the critical values, and then your hypothesis will be rejected. So we call these outside area as the rejection region. Rejection region is the outside, too small or too large. So graphically, it's like this. Suppose that my hypothesis is 30. I believe that the true mean is about 30, but I am going to allow plus minus 1, for example. Plus minus 1 is how much I allow for the random error. But if the difference is greater than plus minus 1, then you are going to think that the difference is too significant, so you will reject the null hypothesis. That's the structure of this decision making. Your decision making is going like this. So rejection region is this area and this area. Rejection region is outside the critical values. Then again, what remains is how to determine the margin. Margin should be determined so that the decision rule is consistent with the earlier, the previous decision rules, like t-statistic approach or the p-value approach. It's also pretty simple. So remember, in the t-statistic approach, the acceptance region is like this. If standardized difference is within plus minus z alpha over 2, then you are not rejecting the null hypothesis. And equivalently, you can rewrite the inequality in like this. And simply, it is also, we have done this in the confidence interval chapter. Isolate x bar in the middle and multiply this guy on both sides and add mu 0 on both sides. And then in the end, this inequality is equivalent to this inequality. So if x bar lies between mu 0 plus minus certain margin is equivalent to this, which is the decision rule. So we are going to use the same decision rule, this decision rule, for the critical value approach. So, and naturally, this part is the margin. It tells you that this should be the margin. The margin depends on z alpha over 2 and standard deviation and the sample size. So the critical values can be calculated like this. And once you calculate the critical values, the decision rule is based on those two cutoff. So between those critical values, do not reject. Outside the cutoff, you have to reject. Right? The idea is, again, the margin is how much you allow around your hypothesis. It's simple and straightforward. And first, let's compare this with the confidence interval. They are pretty much the same, parallel, exactly the same, but the philosophical approach, philosophically they are different. So confidence interval has no hypothesis. You just look at the data and you guess where the true mean is. That is the process of estimation. But now we are doing hypothesis testing. That means before looking at the data, you have a certain hypothesis about the true mean. You believe that the true mean is mu 0. And from there, based on the hypothesis, you are going to compare the data with your belief. So, because of that difference, confidence interval is centered around the data, the sample average. But critical values are centered around your hypothesis, right? Hypothesis is so that's the starting point. And the confidence interval will be correct if it contains the true mean. But critical values are used in a different way. It is compared if these critical values, the interval made by the critical values contain the sample average from the data, then it's not about wrong or then it says your hypothesis is likely to be correct, right? So estimation and hypothesis testing is quite different, and the terminology is also different. Within the confidence interval, confidence level is denoted as 1 minus alpha. So usually 90%, 95%, or 99%. But I really hate this. But in hypothesis testing, significance level is using alpha, like either 1, 5, or 10%. So oftentimes, I say confidence level of 10%. I was supposed to say 90% confidence level, but sometimes I say 10% confidence level because I'm confused with these two structures. But it's pretty clear what I'm saying, because I'm not going. I will usually the confidence level is greater than 90%, and the significance level is lower than 10%. So it's usually clear what I wanted to say or what others want to say. Just annoying notation. And now let's compare the critical value approach to the other two approaches. the major difference is this. In p-value and t-statistic, you when a statistical program calculates the p-value or the t-statistic, yourself have to compare the results with your own significance level or the cutoff based on your significance level. However, in the critical value approach, you have to define the significance level first, because remember, you need alpha here. Alpha is required to calculate the critical value. So in a statistical program, you have to set what is the significance level to calculate the critical value. But what is not required in this formula is X bar. The sample average is not required at all. So if your significance level is given, then you are going to compare the critical values with the sample mean. Then why is it and sometimes in some cases the critical values are more useful. Like for example, suppose that you are going to use the test to a lot of different data, right? You have data here, and once you set the significance level, and then you have the critical values, and using the critical values, you can apply the same decision rule to data 1, data 2, data 3, data 4. Just calculate the sample average from different data. Then you can simply repeat the decision rule again and again. So that's the advantage of using the critical value approach. So in our examples and in the next chapter, we will use the critical value approach more seriously because it is useful in that sense. Okay, and then again, let's think about this. Finally, what happens if the significance level increases? So in the p-value approach, it was clear that alpha increases, then you are going to reject the null hypothesis more often. And then that means in the critical value approach, the rejection region should expand and the acceptance region should shrink, right? So that means if alpha increases, you have to reject more, so the critical values should be narrower to each other, close to each other, right? So this is typo. Critical value should move toward mu 0. So this is typo. I'm sorry about this. So to expand the rejection region, the critical values should be closer to the hypothesis. On the other hand, if the standard error increases, there are more noise, so you have to allow more margin. With the same significance level, still you have to expect more difference on average. So you have to have enough margin to accommodate the larger random error. So this is a simple experiment we can do in our minds. I'm sorry about this typo. I will fix it before uploading the slides with this video. Okay, in the next video I will give you an example. So see you there. Bye.